All right, folks, we've been talking a lot about cloud native, cloud neutral, platform engineering, DevOps. We talked about platform engineering and k0rdent, one of the open source tools there. And a very warm welcome again to Hyderabad. It's a very warm city, seventh time here for me. I think second time here for Bharat. He has already spoken at the CNCF Hyderabad meetup. Now here to Prithvi Bharath. I'm a community manager and developer advocate at Mirantis. I'm a CNCF ambassador as well. I used to work with the Litmus chaos engineering community, but right now I'm helping the k0rdent and k0rdent community alongside the OpenSDA community. I'm also one of the co-organizers for the k3 Bangalore and Platform Engineering and Resilience Engineering Bangalore group. And I recently joined the Cloud Native Kolkata community, so I'm just helping support that community as well. Bharat? Good afternoon. I'm Bharat. I work in the Oslo office at Mirantis. So yeah, my journey has been into Kubernetes for the last like 5 years or so. I worked with companies like Red Hat and smaller companies like Cicada, where I've been an ardent user, consultant, developer of Kubernetes and different aspects. So from the Oslo perspective at Mirantis, I'm getting more involved in the open source communities and the ecosystem, the tools and technologies projects that are supporting this amazing ecosystem. Yeah, excited to be. All right. From an agenda standpoint, I guess we find out. Obviously, we are talking about platform engineering today. We'll dive deep into a little bit on the platform engineering side, but we'll also talk about the tools. We don't have time for the demo, or we don't want to cover the demo today, but yeah, we are open to that one when we in the unconscious session. So how many developers do we have in the room? Like pure developers who are just focused on development. And it's just a sense from my side, but I have to document what developers are expected to do. Then it is this. They are expected to learn tools part of the CNCF landscape. They are not just asked to write code, they are not just asked to develop. They are also asked to learn new tooling, implement them, do the outside of things. So basically, a developer, the developer is not a developer. He or she is a QA engineer. They are supposed to do DevOps. They are supposed to do SRE stuff. They are supposed to do platform engineering. So the developers in itself are being burdened today. And platform engineering as a concept has come in. There are different teams. Complex teams like developers are facing a burnout. There's a developer experience that is being tarnished. Developers are burned out. They don't want to learn new tooling, and that is in return not helping anybody. So customer confidence is low, and expectations are very high in organizations, and developers want change. Developers are coming to me and asking, how can I be a community manager? So that's something that is interesting in today's world. And if I have to ask, how many DevOps engineers are there? Okay, I think there are more DevOps engineers than developers in the room. And I believe DevOps started as a culture which wanted to reduce the cognitive load on developers, and it wanted to resolve a lot of things in terms of delivery, CI/CD, and even with DevOps, there are so many challenges that we are facing. Before DevOps, application developers focused primarily on writing code, but software delivery was slow, and there was so much of manual ticketing, and we were facing so many issues that after DevOps, even if software delivery sped up a lot, developer experience is still suffering because there are so many DevOps team in a particular company. One team is implementing something for the CI/CD steps, one team is implementing GitLab, Jenkins, then there is another team which is implementing almost drone. And then there are so many enterprise tools. I was talking to one of these community folks and uh, uh, trying to suggest that they are using Linkerd as well as Istio. And then I was surprised, like how many service meshes do you want? And let's be honest, developers just want to focus on writing code. And that is where platform engineering evolved to reduce a lot of this uh, cognitive load, trying to make operations simple, developers were benefiting beyond what DevOps was doing. And the idea was to standardize all of this, use particular tooling, use certain tools which where it is packaged as a platform. But let's be honest, is DevOps actually dead? Like, there's a lot to talk about, but is is DevOps actually dead off now? Like, have we moved past the DevOps ecosystem and are we moving into that ecosystem where DevOps will be nullified? I believe that in 2, 3 years from now, people won't be hiring DevOps engineers. That's for sure. Like DevOps won't be a role. But I still believe that DevOps is going to exist. I still feel that platform engineering is going to be under the umbrella of DevOps. DevOps cannot die. It's a culture. It's not a technology. Really needs to ensure that your software is being delivered right, platform is being delivered right, and platform engineering in itself will come out as a product. Like platform is seen as a product today, and that is where I feel that DevOps engineers will not worry about it. But I feel the transition should be ensuring that you are building the right product for the right approach and the use case. And that is where, when cloud computing first emerged, people believe that it's going to be an interaction between a data center and your cloud. But this is what we are seeing today. I mean, if you are on a multi-cloud environment, people are using Azure, AWS, GCP, VM, bare metal. I mean, there are other cloud providers as well, Tivo, DigitalOcean. So we have a battle between these vendor stacks and the idea of public cloud environment, hybrid cloud or private cloud environment. That is where container orchestration became the idea behind making it simpler, and we had Docker Swarm, Apache Mesos, Kubernetes coming in, and Kubernetes was seen as a right container orchestrator. I mean, make no mistake, Kubernetes is a powerful orchestrator. It is a powerful scheduler. But are we utilizing Kubernetes the right way? Yes, Kubernetes has matured. Every other cloud provider in themselves have created an open source, open standard of their Kubernetes providers like GCP, Azure, AWS, data centers, edge environment. But has Kubernetes been implemented as a common control plane? I believe the idea is to implement Kubernetes as a common control plane, which removes all these API layers under the hood, all these services under the hood. And a thin layer of Kubernetes will let us use all these services cloud together. And let's be honest, platform engineering, as I spoke about, it is not a new concept. I mean, it has going on since years while building internal tooling, internal platform, internal infrastructure. The shift towards product thinking is necessary today. You need to put forward your platform not just as a service. I mean, there are so many platform as a services out there. There's Heroku, and even I believe that Cloud Foundry as an open source solution has been very prominent. But I believe that while organizations focus on a shift towards product thinking, it's not just about automation and infrastructures anymore. It's also about creating a scalable platform where whichever tool you are trying to add, let's say you are trying to add chaos engineering, you are trying to add incident management, you are trying to add logging, matrices, anything, you are able to scale it and automate it. And what's platform engineering in my opinion? And we will talk a little bit about platform engineering and the challenges it possesses. In my view, platform engineering is the discipline of creating and building an internal developer platform, which, where the self-service layers and the software delivery is eased out, secure, and possesses less friction. And this think an identity as a developer's office. Like, let's be honest, you are trying to pre-configure your CI/CD pipelines, you are taking care of your security gates, provisioning, But building an IDP is not just about integrating tools, but it is also about crafting an experience where the infrastructure becomes a product that developers are using. And if I have to be honest, I mean, this is how I have envisioned platform engineering, that your developer teams are interacting with the platform, which is built by a platform team, and they have a standardized approach, and they have an approach where different developer teams, I mean, even if they are multi-tenant, even if they belong to different regions in itself, they are able to interact with the platform robustly, and they are able to interact with the platform without being so for the resource. And let's be honest, I mean, why is platform engineering considered today? I mean, production releases are happening every month. There are manual and repetitive tasks. You need to automate them. Cost is a concern. I mean, outages can cost lots of billions and billions of dollars. And consistency is key. It's too hard to manage, different pipelines, as I spoke about. Different teams are managing tools. You need to ensure that you're managing them with a standardized process. And that is where the idea was to shift on how we are using Kubernetes. I mean, clusters are not meant to be namespaces. You need to have an open standard approach towards using the APIs. It has to be infrastructure agnostic. Even if you are in a multi-cloud, hybrid cloud environment, you should be able to run all complex applications, and obviously a declarative GitOps approach, where you are able to manage different states and able to ensure that it is reusable and repeatable in nature.
Sure.
So why are we not there? Because obviously we have a lot of issues today. There are multiple controls, there are so many tools in one platform, as I spoke about each and every organization. You'll see that there are 10 tools that they have purchased, licenses, they are already implemented the open source side of things, but they are not using it. It's that they are paying their license fees, but they are not using the tools in itself. There's a product idea misfit. I mean, they know what product to build, they know what is their idea, but they don't know how to implement it. And then the golden path, obviously, golden path of it is an executable perfect path for your platform to interact with your developers, but golden path with feedback loops, the developers are not able to provide the right feedback on the platform, they're missing out on something. And again, multi-cluster business scale. Even if you are on a multi-cloud, multi-cluster platform, you're not able to manage it, and there's a lot of outage when we install the research services are not in place. And that is where I believe platform needs to be democratic. This is my last slide before Bharat takes over. And I was talking about it in one of my blogs. And the idea was that platform engineering has evolved through multiple stages, from the development side of things, operation side of things. There is the DevOps teams that are shifting towards platform engineering. The bottlenecks are true, and the demand has scaled, obviously. To implement this or to address this, I believe the idea is to have a platform group in place where your SREs, where your developers, where your DevOps engineers, where your leadership group, all of them are participating together, your infrastructure teams, and you are able to address inefficiencies. I mean, I wrote one of these blogs. You can check it out on the CNCF blog page, where I talk more about platform democracy. And I think conclude that platform democracy should be implemented as a model where all the stakeholders are participating equally in producing and consuming platform capability. And this shift basically ensures that the ownership is not at one point, but the ownership is distributed. But in the end, you are redefining the roles and making sure the producers as well as the consumers are helping build the platform. With this, Bharat takes over to talk a little bit about multi-cluster configuration and coding as a tool to leverage your internal developer platform. And in the end, we can take questions in the conference session. All right. Problems, right? That's what we've been hearing. A lot of challenges, big gaps to fill in. Let's take a look at the needs for platform engineers, right? So Prithvi nicely handled in sort of portrays a picture of how the journey in cloud native space, the Kubernetes space, the DevOps space, and then now finally the platform engineering space as well, especially when you talk about multi-cloud multi. So I just want to talk about two things over here. Hybrid multi-cloud has almost become the norm. There are surveys done where 76% of the organizations have adopted two or more clouds in their enterprise or even small scale businesses, not just big companies. Now, when 76% of the people have adopted multi-cloud, just about 29% of them have good platform engineering practice. That's a huge gap, right? So this is about one cloud, and then they start adopting another cloud, then one more, because of the requirements and the teams that come into place. But then there's no uniform handling and proper, maintenance of all these platforms which leads into overnight. And the second thing we're talking about is AI ML part, which is a huge challenge and opportunity for platform engineering teams to lead it nicely. Because now, no matter what kind of a company you work for, the product you have, it's now, I think, the future that AI is going to be integrated into your workflow, right? Now, when this is the reality, we need to focus on creating or integrating the AI and ML workflows into our platform engineering journey. So, like we said, Kubernetes as the orchestration fabric for the future is very vital because Kubernetes offers a lot of things internally and the design of Kubernetes itself that helps to solve a lot of these problems. So if there was no Kubernetes, kind of challenges that we'll need to tackle individually and solving a problem by scripting or protocols and processes. A lot of these are inherently handled by Kubernetes. And that's why we believe that platform engineering run on top of Kubernetes, that being the main orchestration fabric, is one of the cool solutions out there. Now, the multi-cluster platform engineering challenge I talked about that, right? It's something related to what I just mentioned a while ago in terms of managing the operational complexity and managing the policies, enforcing security from the ground up has become a lot of practical challenges that DevOps and platform engineering face. And to top it all off, the last one that mentions Kubernetes crawl is a thing that we're seeing more and more. When we talk to our customers, we notice that they have hundreds of clusters across clouds, and nobody even knows where the workloads are running. Where do I scale it up? Do I do vertical scaling, horizontal scaling? Right? So the Kubernetes crawl has become a real challenge. Now, if I talk about the options that we have for multi-cluster platform, of course, there's the good old option of doing nothing, wait until things really get over, then things get escalated, and then it's better. And then there's the VR open source. So now I'm going to enter a little bit into the open source world to address all the challenges that we've talked about. Open source community and projects and ecosystem in the Kubernetes space is awesome. Kubernetes is what today, after 10 plus years, we call the open source nature of it. We have solutions for pretty much everything, like observability, security, CI/CD, IDP, you name it, and there's an open source solution for it. But how do you pack all that together? How do you bring them all together and do it, in a streamlined manner is the challenge with AI or no. Then there's the proprietary solution. So if you think about, a lot of you who raise your hands for developers and DevOps engineers will definitely have this experience that I can go to AWS Cloud, and then just click a few buttons and then I have a cluster, right? I need to add a service, I give services, add a service. So this is true for not just AWS, but GCP, Azure, and VMware and all. But what happens with a vendor offering proprietary solution is that the expenditure, the costs, and the policy management, everything becomes complicated and difficult to manage in the long term. So we've seen a very famous example of Broadcom's acquisition of VMware. Again, I'm just taking that as an example because all of us understand it. There have been many smaller instances as well where companies are planning to challenge specific vendor offering. And that's where I want to talk about the fourth one, right? Red Hat, almost 30 years of business business, the workaround has been in this enterprise grade open source. It has worked through this from the 90s when it started distributing enough of it, all the way to 2025 and has amazing Kubernetes solutions. So in this case, if you want to address the sensor missing layers, the entire IDP, platform, that's where it's right, and that's where I want to introduce k0rdent to you. So what is k0rdent? It's a distributed container management. What that means is it is cloud agnostic, it is vendor agnostic. We have support for multiple clouds out there. As long as any cloud has support for cluster API, which is going to cover in a minute, we have it. Right? So what k0rdent enables you is this enterprise grade open solution, but at curated packaged way. So how we deliver that curated packaged way is by enabling the template solution. So as long as an application has a health chart, it can work on k0rdent, right? That's the first part. As long as any of the cloud providers have delivered health charts, the two, it can work on k0rdent. So template solution in the open source panel with the enterprise grade technology is what k0rdent offers. Right? So again, don't want to spend too much time, but we already sort of talked about this journey starting from like 2014, 2015, when it started, all the way from Gen 1, Gen 2, Generation 3 and 4 now, where the fabric manager, central part of it, is where we want solution for it. So very briefly, k0rdent has three main architectural components: cluster management, state management, and observability. I'm going to start with the third one. Observability, all of us know, right? Whatever product we build, it's not complete without observability platform built. And that's what it provides. Again, using the open source solutions like Kubernetes, Grafana, OpenCore, OpenTelemetry, and so on. Then the cluster management, state management are sort of mirror images for different purposes. Your infrastructure configuration is defined by the cluster management component, and your services, which is the native stuff, is defined by the service master. So for cluster management, we use and we extend cluster API. So if you guys go to cluster API CAPI, it's the standardized way to provision clusters using predefined controllers that are accepted under the Kubernetes, right? And because it's a generally accepted solution across the industry, every cloud provider has their own implementation of CAPI. So I have to the upstream one, CAPI, that is Kappa for AWS, Kappa for OpenStack, Kappa for Azure, and so on, have their own individual cloud provider. And that's what we utilize in clusters, right? And on the right side, I think it's a bit small, but that's basically the single YAML file that you interact with to define your cluster template. Corresponding to that is the mirror image what I told you for the two services, which is the service center. So basically like this, that okay, you're now being provisioned a cluster, right? I have access to the cluster, but without installing the appropriate services, what use the automated cluster provisioning for me? So third manager is chill. All these common kind of services that no matter what kind of application you develop, you end up using. So we can just specify the services in the YAML file and that's it. k0rdent will pick that up, and then once the cluster provisioning is completed, it automatically deploys these services on this demand is that right. One cluster deployment with top cluster templates and then the service. That's it. Infrastructure configuration and your service configuration, one single YAML file that provisions your entire cluster and installs. Then I have already talked about the observability part. Just a little bit of addition to that, we also have the extension of this for FinOps. So since we've integrated open cost, we're building on top of that to also give you a cost management platform where the managers address cost in a single dashboard across your cloud. So this is again a challenge that we discovered during the surveys that we've done where
we have one more talk and then we'll go.
Google
Yes, well.
Cloud Manager, but the centralized cost management dashboard and a cost analysis that is done across, for your entire infrastructure. Think of that, something that, we. So let's talk about a few components in this open source. Because I already mentioned customer API. K0rdent and Cosmotron are typical components. So k0rdent is a Kubernetes distro. So you guys want to put K3S, K3D, and so on, right? So k0rdent is the lightest Kubernetes distro, which runs as a binary, a single lightweight binary on your platform. So I'm giving a talk actually on k0rdent in the upcoming KubeCon, where I'll demonstrate that a controller is running on some remote VM or on your laptop, and then something as light as a Raspberry Pi or an edge device can be the workload for it, where that combined with the controller will become a Kubernetes cluster, right? And then we have Cosmotron, which is the control plane manager, and k0rdent being the umbrella for all this, like sort of the supercontroller, right? And just very briefly, the catalog is the one that powers all these services. So catalog.k0rdent.com, you can actually go and see all the services. Next, I'm going to hand it over to Prithvi, who will try to the next part. We talk about how to contribute to coordination to the top, and we have understood that coordination is the super control plane, which is helping you manage your multi-cluster, multi-cloud configurations, and it follows a templated approach where you use different templates to basically empower them. The super part about Kotlin is also you can use your own hosted control plane, helps you empower this uses Cosmos which is helping to empower different applications. But as I mentioned, it is open source, you can contribute to it. So how can you contribute to it? I mean, check out the Kotlin GitHub. Most about the project is obviously available on GitHub. So then the website itself, you can import it, you can take a look at the Kotlin Cluster Manager, which is the KCF repo, the KOF repo, which is on the FinOps and observability side of things. And then you can also check out the docs, which can help you implement Kotlin your environment as well. Join the Kotlin community, it's on the CNCF Slack, so you can just check out hashtag Kotlin to the CNCF Slack. This is the QR to join the CNCF Slack so that you can ask your questions, you can be a part of the discussion. And in the end, we are giving out some limited edition k0rdent t-shirts. We just selected 100 for India. So we have got 40 of them here. So if you can scan the quiz and follow the quiz, answer all the questions, the catch is you have to be the first 40 to answer the right questions, and you can grab the t-shirts and the stickers. So we will reach out via email during the meetup itself who are qualified for it, and you can talk to us and select them. So thank you so much once again from me and Bharat, and appreciate your participation in the CNCF Hyderabad community. And thank you so much to the Tech Mahindra team for organizing this, and Atul and team for hosting meetups every month for CNCF Hyderabad. Thank you so much. Appreciate it. Thank you guys. And we'll be happy to just have a quick chat, just have a word and get to know your cloud journey. And let's have a Thank you.